Here are the exercises for chapter 15. We'll start simple and then we'll get progressively more and more complex. I'd like you to create an array of 150 floats. And I use the word array in inverted commas there because sometimes it may be an array and sometimes it may be a bit of memory got from the operating system that you're going to treat as an array. I want you to create it in three different ways. First of all, create it on the stack. Secondly, on the heap. And thirdly, in static memory. In other words, I want you to use all three different types of memory that you have available to you. You don't need to do anything with the array, I just want you to see if you can declare it properly. If you declare it on the heap, make sure you free it again afterwards and also make sure that you check to see that you actually got a valid piece of memory. Next, create a program that asks the user for a series of numbers, then calculates the average of all the numbers that it got. The number of numbers, in other words how many numbers they're going to enter, should be the subject of the first question. So the program will simply say, how many numbers do you wish to edit? And you'll say maybe 9, and then the program will ask you for 9 numbers. And then when you get 9 numbers, it will give you the average of those 9 numbers. Okay, next, modify the course project. And this time, we're not going to use a stack array of CDs, nor are we going to use a static array of CDs. We're going to actually ask the question at the beginning of the program, how many CDs do you have to enter? Allocate memory for that many CDs and prompt for the CD details accordingly. Now, how is that going to improve our course project? Well, imagine this. We run the course project and the first question we get is how many CDs do you have to enter? And we say 2. And then it prompts us for the details of those 2 CDs. How has that helped anything? Well, for a start, we're not wasting 98 unused elements of the array of 100 CDs. That's what we were doing before. If we only entered 2 CDs, we would be wasting 98 of them. We would be wasting most of a great big array of CDs. And the other benefit is that if we decide at the beginning of our program that we actually have 300 CDs that we need to enter, our program simply won't work. Our program can only support 100 CDs. So we're actually making our program here much more powerful. We can now make it infinitely large. Well, not infinitely, we can make it as large as there is memory in the system. So we can store a very great number of CDs, not just 100. And if we ever need to use less than 100 CDs, then we are more efficient. Anyway, the bottom line is we only allocate the memory that we need, no more, no less. We are much more efficient than we were before. Okay, finally, this is something of an advanced exercise to really see if you can understand pointers and memory allocation. Modify the course project such that each CD uses only the memory absolutely necessary to store title and artist names. In other words, if you had the artist was, say, U2, now U2 is only a 2-character name, so you really only need 3 characters of memory to store the string U2. But we're allocating, I think, 60. We're allocating 60 bytes to store each title and each artist name. So that's wasteful, especially if we've got a great number of CDs. Maybe if we had 1,000 CDs, we could be wasting 30 kilobytes of information. So I'd like you to see if you can have a think about how you might do that. I only want to store exactly the amount of memory absolutely required for each title and each artist. So if CD number 1 is by U2 and CD number 2 is by Dire Straits, then they're going to have different length artist names. Okay, see how you go at that.